Okay, let's do one more example of just taking a derivative, and then we'll do some kind of like tangent lines and all that stuff. Alrighty. Calculate the derivative of, let's get a nice one, ln of tangent of 4e to the 3x minus 5. Okay. Two minutes. Or whatever we had last time. 2 minutes and some change.
In this case, would there be two outside functions?
Maybe. I want you to think about that and try to answer that for yourself. Okay. So, how do we do this problem? Yikes. Lots of chain rule. Lots of chain rule, right? So this is a chain within a chain within a chain, right? Okay. So it's like a bad movie by Christopher Nolan. Right? Who did I just offend in chat? Yeah, no one. Right. Making something complicated doesn't make it good. Okay. So we used chain rule several times. He doesn't make bad movies. I mean, I enjoyed Inception, so I mean, I'll watch it. It's a fun movie to watch. All right, we used chain rule multiple times. Right, so there's no products, there's no quotients, nothing. It's just a whole bunch of compositions, right? So let's actually rewrite this function and let's highlight each of those parts. So ln of tangent of 4e to the 3x minus 5. Okay, so the outermost function is this ln function, okay? Then we get the next function, which is tangent. And then we have the next function, which is this function where I have 4e to the x, where it's like 4e raised to some power, right? And then finally, the last thing we have is 3x minus 5. So we have 4 functions here. So that means, now we know that chain rule, however many functions you have kind of nested within each other, that's how many terms you're going to have, right? For a normal, like one application of chain rule, there's an outside and an inside, and each of them gets a derivative. So that's 2 terms. Here we have 4 separate functions. So I'm going to have 4 separate terms, each one corresponding to a derivative of each of these terms. Okay? So the first thing is, when I take this derivative, I need to differentiate the outermost function. Now, what is the derivative of ln of something? It's just 1 over whatever is already there. It's 1 over whatever. So I get 1 over tangent of 4 times e to the 3x minus 5. So that is coming from the derivative for ln. Now, chain rule then tells you you have to multiply by the derivative of the inside function. Now, what is inside with respect to ln? So you kind of peel off the ln. Whatever is left over is the inside function. So I need to multiply by the derivative of this inside function. But that inside function itself is another composition. So you're kind of not going to restart. Okay, focusing your attention just on this function, that's a composition. The outer function is tangent of x. Its derivative is secant squared. And then chain rule tells me, okay, now multiply by the derivative of that inside function. But what's that inside function? Peel off the tangent. And now I'm left with 4e to the 3x minus 5. That's the new inside function. But that itself is a composition. Its derivative is just 4 times e to the 3x minus 5, right? That the derivative of e to something is just the same exact function, right? You don't really do anything with it initially. So that term is coming from taking the derivative of the pink term. And then finally, okay, I need the derivative of the inside function of that. So now the 4e is gone, and the only thing I'm left with is 3x minus 5. And the inside function, there's no inside function. 3x minus 5 is just a function I can differentiate. No more chain rule or anything. So I just need times 3, and that's it. And then we can kind of peel off all of these layers again. So that's how chain rule works. It's like peeling off layers of an onion. So we have this function that's kind of 4 functions all in one, and we can peel off one layer at a time. And you get a derivative for each layer, right? Derivative of ln is 1 over something. Derivative of tan is secant squared. Derivative of e to something is the same exact thing. Derivative of 3x minus 5 is 3, right? Notice how there's a derivative for each term. Okay.
Dr. J.
Yes.
I have a quick question. When you did the secant squared and then the 4, like that one, and then you took the derivative, I didn't put the 4 in front of the e. Wait, is that, but like, if you take the derivative, isn't it like product rule? And
well, you can use product rule. That's 4 times e to the 3x minus 5, but you don't need product rule because this is a constant coefficient. What do we know about constant coefficients?
they just hang.
Right, they just hang around.
Okay.
Exactly.
Yeah.
Product rule will give you the same thing, but it's just overkill.
Okay, thank you.
You don't use it where it's like equals 0?
You can, like I said, you can use product rule. I mean, if you had, say, 3 times x squared and you use product rule, you get what? 0 times x squared plus 3 times 2x, and that goes away. So you could have just done the coefficient times the derivative of whatever was left over. So product rule doesn't give you anything wrong. It's just kind of overkill to have to keep applying it.